In this example, we're going to talk about the symmetry again, and then we're also going to do our x and y intercepts, making sure that we remember how to do that from an equation. So first of all, let's test this equation for symmetry. Now remember, we have three different tests. We have x-axis test, we have y-axis symmetry test, and then we have origin symmetry test. So we're going to perform all three. Okay, so for x-axis symmetry test, if you'll remember from the definition, it says that we replace the y with negative y and see if we get the same thing. So in this case, I'm going to say negative y equals, here's my original equation up here, x squared minus 4 over x. Now, even if I get the y alone, it's just going to transfer the negative over to the other side. So we can hopefully immediately tell that there will not be any x-axis symmetry in this problem. Let's try y-axis. Back from our definition, it said to replace the x's with negative x and see if we get the same equation. So we're going to have y equals, instead of x squared, we're going to do negative x squared minus 4 over negative x. Now when we simplify that, negative x squared is positive x squared minus 4 over negative x. Now again, this is not what we started with. The y and then the numerator are the exact same, but the denominator is different. So even if I move that negative up to the top, or if I move it to the other side, it doesn't matter. We're still going to have a different equation than what we started with. So there is no y-axis symmetry here. Let's try the origin. If I replace, for origin symmetry, we have to replace both the x and the y with negatives. So negative y equals negative x squared minus 4 over negative x. So now here we have negative y equals x squared minus 4 over negative x. And you know what I'm going to do to get rid of this negative x here on the bottom? I'm going to multiply both sides by a negative 1. Now when we do that, negative 1 times negative y is positive y equals, when we multiply, remember we can cancel tops and bottoms. So this negative will cancel from the bottom. And we have x squared minus 4 over x. Now this is the exact same equation that we started with. So yes, there is origin symmetry in this problem. Alright, now I also want to go over x and y intercepts here pretty quickly, because since we're dealing with this equation, it gets to be a little bit more difficult. So, or I say it's more difficult, it appears more difficult because of the equation and especially the fraction. So let's look at the x-intercept. Now think about what we know about every single x-intercept. Every single x-intercept has a y value of 0, so let's use that. Let's plug in 0 for y equals x squared minus 4 over x. And let's solve this. Now, because this is a fraction on the right-hand side, we can put the 0 over 1 so we can see fractions, and then we can cross-multiply. So 0 times x is 0 equals 1 times x squared minus 4 is x squared minus 4. And then we could move our 4 over to the other side to get 4 equals x squared. And then taking the square root of both sides, we get plus or minus 2 equals x. So that means we have a negative 2, 0 and a positive 2, 0 for x-intercepts. Now for y-intercepts. Every single y-intercept has an x value of 0. So let's use that. So y equals 0 squared minus 4 over 0. Well, right here is a big major problem. We cannot divide by 0. That becomes something that is undefined. So that tells us that there is no y-intercept in this problem.